All right, hello everyone. My name is Timothy Lee Grant, and I am going to today continue where we left off here, which was last video, maybe like 20 minutes ago. I did this one, search a 2D matrix. Now it's time to try to do the next one, which is Koko eating bananas. So let's try it out. And we're in the binary search section. Okay, so you're given an integer array piles where piles of I is the number of bananas in the ith pile. Okay, you are also given an integer h, which represents the number of hours you have to eat all the bananas. Okay, you may decide your bananas per hour eating rate of k. So I get to decide k. Each hour, you may choose a pile of bananas to eat k bananas from the pile. If the pile has less than k bananas, you may finish eating the pile, but you cannot eat from another pile in the same hour. Okay. Return the minimum integer k such that you can eat all bananas within h hours. So I'm given the number of hours that I need to do. I'm trying to even conceptualize this problem right now. So I can see what it's talking about regarding, like, I get to choose k, which is how many bananas I eat per hour. Okay. And I know that I need to eat all the bananas within h hours. Okay. How do I solve this? So obviously this was within the binary search section, but I don't see how a binary search can apply here because I'm not searching for anything. I'm trying to minimize a value. So if I look at this, I have 9 hours to do it. So what if this was 1, 2, 3, 4, right? What if it was 4? That's the minimum number of hours. I would need to eat 4 bananas per hour, right? Because I would eat 1 banana here, and then I wouldn't be able to move on to the next one. Then I would eat 4 bananas here, and I'm done. That's my 4 bananas in 1 hour. Then I come here and I eat 3 bananas. I can still eat 1 more, but I can't, I can't move to the next pile. Then I would come here and eat these last 2. So that would be 4 hours, okay? So if the number of hours equals the number of pile, I need to grab the largest pile. Let's say instead of 4, the number of hours was 5. Does that change anything? So return the minimum integer k. Well, yeah, I don't know. Let's go look at the solution and try to find out what's happening. So Python here, we're iterating through what? Total time. So, well, first off, I don't think that this is binary search. But we're iterating through each of the piles, okay? The total time, so the total time plus equals math.ceiling pile divided by speed, and speed is 1 right now, okay? So if total time is less than h, return speed, otherwise increase speed by 1, okay? Okay, is there a better? Okay, here's binary search. So hold on, Susie just sent me a message. Oh, okay. All right. Okay, so for this one, it is, we're setting left is equal to 1, and right is the largest pile. So this was 4 in the last example. Okay. Now, result equals r is 4, which that's what I said previously. Remember I said that we were at the largest value? Like the most amount of bananas dictates how many we can eat at the if the hours are equal to the number of piles. Okay. So now I know this formula is midpoint, okay? So something about k, so k is now midpoint, okay? And total time is 0. So we are iterating through, so each time we look at this, we iterate through all of the piles. Total time is math ceiling, okay? Float p. So the number of items divided by k, which k is the middle point, okay? K is the middle point. I'm not sure. She just sent me a question mark. Okay. what this would do. Like, why are we accumulating time? So this is the total time that it takes to eat all the bananas. If total time is less than h, we can set our midpoint to be the result. Where is result? No, result is equal to just the midpoint, and then we set our right. What is going on? We set our right equal to k minus 1. L is k plus 1. Oh my gosh. Okay. So total time is equal to, is it just sending me? Oh, okay. She said that she had food today. Because I was trying to bring her food to her office, but I can't get into her office. So I sent her a text message and said, hey, do you want to come down? Because I'm at the entrance of the building. And I sent that like 5 hours ago. And maybe not 5, maybe 3 hours ago, something like that. And she just now saw it. So that's okay. That makes sense now. Anyways, we were trying to understand this P in piles. So total time is 0. So each time that I do this, so I have my left and right. Okay, fine. And I find a midpoint. But I don't get. So left is 1. So I'm doing a binary search of the number of hours. Not number of hours. The number of speed. So it's somewhere between. Okay, so it is somewhere between 1 and the number of or the maximum number of piles, right? Or not number of piles, but like maximum number of bananas within a single pile. Okay, so that's somewhere. We first take result is equal to the largest. Okay. So that was, for example, in here. What's that? Oh. In here, I said, okay, well, what is the worst case scenario? It's 4, right? Like, I will have to have a eating speed of 4 because this is the largest one, and that's going to allow me to finish the pile as quick as possible. But it's at the largest eating speed. We want the lowest eating speed, okay? So that's what we are doing here. So we're setting result is equal to the maximum right now. Then now we're going to try to go through left and right, where left and right, left is this eating speed of 1, right is an eating speed of so far the maximum. Okay, so we find a middle eating speed, then we calculate the time. So total time, we're accumulating this for each pile. Math.ceiling, okay, so we're taking the ceiling, so float P, so the number of bananas in the pile, divided by the eating speed. So this is how many hours it takes to eat that entire pile. And we round up. That's why there's the ceiling. Okay, and then we add that to the total time. Okay, so now if the total time is less than h, meaning h is our valid number of hours, so if it's valid, then what we can do is we can set result is equal to this current eating speed. Okay, the current eating speed. So now it used to be the largest eating speed. Now we shrunk it down a little bit. Okay, and then I can move my right eating speed over by my mid over by 1. Now that gets rid of all of the higher eating speeds. So that's why we can never replace this number again with a greater eating speed. We don't need to check like if result or if k is greater than result. We don't need to do any of that because in this line we just got rid of all of the larger potential eating speeds. Otherwise, like if it's invalid, okay, now we need to shift our leftover by the current midpoint plus 1 and then do another midpoint and then return the result. Okay, conceptually I'm starting to kind of understand how this is going. I'm gonna have to think through it a little bit. I'm also gonna have to think through this one a little bit. I feel like it's a good problem in terms of like, okay, well, I wasn't even able to think of the brute force method. That's something that I need to think about and put in my head. So I'm glad that I was able to see this problem. Unfortunately, I wasn't able to solve it, but it was a good learning opportunity, and I'm going to try to mull it over in my head and improve on this situation. So thank you guys for watching this video. I hope you have a wonderful rest of the day. My name is Timothy Lee Grant. If you liked it, subscribe. I would love to have you around, and goodbye.